Hello everybody. Welcome to Take Pandit session. This is Dan. Today I'm going to show you how we can connect AWS Athena from our local DBeaver client and query the tables in Athena. So Athena. So Amazon Athena is an interactive query service provided by AWS to analyze data which is stored in Amazon S3 using standard SQL service. So it's a serverless service and there is no infrastructure to manage. And we only pay for the queries that we run. It's very easy to use and it's a simply we just need to point to the data which is stored in S3. Just define the schema, means you just create the tables based on the structure of the data inside the files, and then just start querying the data using standard SQL, like select star from table. And within minutes, you will within seconds, I would say, your data or the query output will be delivered. So there is no need to manage like databases. There is no need to manage like complex ETL job or prepare the data for analysis. It's very simple, very useful if you have the required data in your files and you just want to query it. So no need to load the data into a database and then query it. Actually, in fact, I have seen like in many places where in few other places, like I would say, where business wants to query the data before it's stored into the databases or warehouses, or they want to check the quality of the data, the raw data, so they can straight query it from the files before it goes into the warehouses. And the most important part is that this Athena is very much integrated with Glue, AWS Glue data catalog. So if we have any data catalog in Glue and that is connected to S3 backend, like the data in S3, we can straight away query them through Athena. So it's like a unified metadata repository across various services, and then you just query the data. And the best part is that because the charges are based on how much data is scanned from S3, so we can actually we can create the data by using some partition definition, and we can also version the metadata, and we can reduce our cost. So how much data is going to be scanned, it can be reduced by creating partition and all these things. So, but that's a different area to learn altogether. We can discuss this later. So as you understand, and so this is what AWS Athena is. So what is DBeaver? So DBeaver is an SQL client which we install in our local laptop to query various databases. Like you can connect to Oracle, you can connect to MS SQL Server or Postgres or DB2, any kind of databases. So that's what I'm going to do today. So I'm going to connect AWS Athena from DBeaver and going to query our Athena object. So what is the key benefits actually? So the key benefit is that you will have the same query execution experience. So like when you were querying a Oracle or a SQL Postgres, MS SQL or PostgreSQL database from your DBeaver client, you can have the same experience to query a file data in S3. You think in the same way. You can use like you can use joins, you can use any analytical functions or any SQL functions provided by Athena. So it's very handy and very easy to analyze the data. And you don't need to provide any long-term access key or secret access key. So you no need to, so long-term secret access key and access key is provided by AWS. So whenever you try to connect to any remote AWS services from your local machine, you usually use the access key and secret access key, but by nature they're like long-term. So if you want to stop the that connection from AWS services, you need to delete those access key and again recreate them from next time, something like that. And it is not that secure, I would say, to have a long-term access key and secret access key live. So we don't need to actually provide the long-term secret access key or the access key when we are connecting to Athena through DBeaver. And mostly you no need to go to the AWS management console to query Athena tables. Just open the DBeaver and connect it. So yeah, that's on a high level the benefits. Let's jump onto the demo part of it. So I'm logging to AWS management console, and let's start with by creating an Athena database and a table. So let me go to first Athena. So this is the Athena console. Looks like you can see that the catalog is there. It comes with some default databases and sample databases, but let's create some new database. So what I will do first, I will go to S3. So I will first have an S3 bucket where I will keep my tables data. So let me create a bucket. So the bucket name is demo sample data bucket. I hope this name is available, and just create it. So the bucket is now created. Demo sample data bucket is created. I'll go inside it. There is some error, I don't know, yeah, but it's all good. Demo sample bucket is there is no data in it. So I have a sample file in my, I've created a sample file. So let me see. It's Athena files. So I have this file here. Just I want to show you the content of the file. So if I'll do a head -5 and then emp, so yeah, you can see this is just a dummy sample file. So it has few columns: employee ID, name prefix, first name, middle name, last name, gender, and email, and some dummy data. So it has around it has all this data, and it is a comma separated file. It's a CSV file. So what I will do, I will upload this file into S3. So let me first create a folder inside it. So inside the demo sample data bucket, I'm just creating a folder named employees, and just creating the folder, and inside this folder I'm going to paste this file. So I'm just uploading this file, and let's upload. So now I have, you can see the file is also detected by S3 that it's a text file, probably in CSV format, because that file is having an extension of CSV. So the file is now uploaded. Now let me go to Athena. So now in Athena, I have to create a table and a database pointing to this file. So let's create a file from S3 bucket. I want to create a new database. So let's give it a name of demo DB. Table name, let's say employees, and the bucket name. So S3 bucket name. Let's pull the bucket name from here. This is the bucket name, and inside that the folder name. So employees, OYES. That's all. So this is not an encrypted data, and then press next. It's a CSV file, so the format we have to select. So data format is CSV, and then I have to mention the column names in the file. So what I'll do, I will bulk upload. What I can do, we can give one after another column name and then add it, or we can do a bulk add column. So I will do a bulk add column, but for that what I will do, I will take this header from the file and then paste it here, and just what I will do, I have to specify the data type. So the first one is employee ID is integer, so it's int, and then everything is string. So first name is string, middle initial is string, last name is string, gender is string, email is string. That's all. So these are the columns, so just add them. So you can see that these are all added now. We could have done it like one after another by manually, or just bulk upload, and then press next. We're not going to partition the data, so we're going to create the table. So it's done. So now the table is created, but I want to show you by querying the table. So what we can do, we can just go here and say preview table. Yes, so we can query the data, but there is a minor mistake. There's a minor problem. The problem is that the header of the file is also coming here. So we have to do something so the header will not appear. So header is not the data. So what I'm going to do, I'm going to add one property in the create table syntax, that is skip dot header dot line dot count. So I'm going to skip the header, and how many headers are there? Only one, so one header, and then I will run the query to recreate the table. Hopefully this time I would not see, but it's still coming. So what I will do, I'll just delete the table. I will first delete the table and recreate it again using this query. So run this query. So now I have the table. If I'll query it, yes, now there is no header, so header is now skipped, so I can see the data. Now the next objective is to query this, run this query or query this table from DBeaver. So let's go to the next step now. First thing that now I have to do is to create a profile on my local machine. So through that profile, the DBeaver is going to access Athena. So to create the profile, I need to create a user. So first let's go to IAM console. So IAM console, or the page where all the users and groups and permissions are managed. So let me go to the users screen and let me add one user. So let me give it a name, Athena user, and then I just want to give it a programmatic access, not the management console, because it's just a programmatic user. And then you can give admin, but I'm not going to give admin privileges to this user. So only access to Athena and then S3, because the user has to access S3 bucket and Athena. That's all. And then create user. So the user is created and I have access to this access key ID and secret access key. So now let me create the profile. So to create the profile, let me go to console and create a profile, AWS configure, and then profile is demo. Let me give this profile a name as demo. Enter. It's asking me for AWS access key ID. Copy this access key ID, paste it over here. Secret access key, copy this secret access key, paste over here, enter. And then the region, default region is AP Southeast 2, AP South, oh sorry, AP Southeast 2, and then the default output format as JSON. That's all done. So let's test this profile is correct or not. So AWS, I'm just checking the S3 using S3 service. So just S3 ls using profile demo. Yes, so it's the profile is set up correctly. As the AWS profile is created, so the next step is to connect DBeaver with the Athena. So let me launch DBeaver. Let me start the DBeaver client on my local machine on my laptop. So I'm launching the DBeaver client. So DBeaver 7.3.2 is the version. If you are using in this version or later, I think that should be fine. So the first thing is to connect or create a database connection. So let's click on new database connection and then choose Athena. You can choose any of the sources. So here I'm choosing Athena. Going next, here you need to specify the region. So my region is AP South is 2 under main tab. Then I have to provide an S3 bucket location. So this location is majorly needed because the query results or output will be stored in this bucket and then will be displayed. So this is something like a temporary space you can think of. So let's go to S3 console and create a bucket for this. So let's name it demo DBeaver temp store and hope this bucket name is available. Click on create bucket. Yeah, that bucket is now created. So let me go back to DBeaver. I'll provide this bucket as S3 location and let me give another folder name as a result. So inside this results all the temporaries, all the things will be stored, all the temporary files. In AWS access key, just give some dummy value. AWS secret key, just give some dummy value. Let's go to the driver properties tab now. So this is the important, these two are the very important properties in driver properties that we have to provide. So the first one is AWS credential provider arguments. So here you need to provide a value. So this value is the name of the AWS profile that we have created. So if you remember, this is the profile name that we have created, demo. So let's give this name over here. Then we have to provide the name, another value, which is AWS credentials provider class. So the provider class here is com dot simba dot athena dot amazon AWS dot auth dot profile credentials provider. So this is the name of the whole provider class. Don't worry, I will copy this thing in the description section so that you can easily copy it. No need to remember or memorize it. So com.simba.athena.amazon aws.auth.profile credentials provider. This is the provider class name, and let's test the connection. So I'm testing the connection, and yes, it's connection tested, and there is no error. So let's finish this, and this is the connection I have created. So if you want to edit the name, we can go anytime in edit connection, and in generate section just give them a name like demo Athena, and then this is the connection. Now if I'll connect to the database, just double click on this and it will try to connect to the Athena. And now you can see all the databases. Like if you go to Athena, we can see the databases default, demo DB and sample DB. So now I can see that these three databases, default, demo DB and sample DB. And then I have my data in demo DB. So demo DB has employees table. So if I'll expand demo DB further, I can see the employees table over here and all the columns I can see. So what I'm going to do, I'm going to query this table. So let's open a SQL editor and then execute a query to select star from demo Okay, so demo B is the, actually it was a spelling mistake, it was a demo B database name. So demo B dot employees, that's all. So let's query it. So if we'll do select star, you can see all the results, all the data is here. You can just query it like normal SQL. So you can do a filter where emp underscore id, sorry, emp id equals to 304721, and let's see what happens. Yes, it works as it is, like a normal SQL. So you are accessing as it is, you are accessing a database, source database. You don't worry about it. So yes, that's how you can just easily integrate. You can easily access the Athena. So if you have many more tables, you can just add them over here. You can join among tables. You can use like, you know, analytical function, and create your own analytical query and execute. So you no need to log into the console and do the query. Just remember that Athena, whenever you are querying a data, so it just, the price is based on how big data volume you have scanned. So whenever you are querying, like here I have queried this table here, you can see data scanned. So based on the volume of the data scanned, the charges are applied. So it's the charges are not that much, like when I'm recording this video, the charges are like $5 for 1 TB data scanned. So yeah, just remember that. There are some tricks to partition the data and reduce the scanning time or the scanning volume. Yeah, so that's all about accessing Athena from DBeaver from your local machine without providing the access key or the secret access key. So you have just set up the profile. So here we have set up the profile with the long term key. But if you have like you are using STS or some any other federated integration where you are getting a short term user your short-term access keys for 1 hour or 2 hours, so but you have a profile ready, so you can always use that profile and just access the Athena. So that's all. I hope you have enjoyed. Thank you for watching.
Thank you for watching this video. I hope you like it. If you like this video, please hit the thumbs up. If you want more videos like this, please subscribe to my channel and motivate me to create more content. Thank you.